Welcome to Physics Problems One by One.
So here is a problem. As always, read it, maybe once, maybe twice, and then pause the video and try to solve it yourself.
Today is part 4 of our problem about two cars. One is catching up with another and another starts with some delay. So point A, point B, V1, V2, distance D, and there is some delay. The first part we had derived this formula. And this formula worked for us, and it was a straightforward approach. In the second part, we put some numbers. Actually, we used four scenarios. 1, 2, 3, and the fourth scenario is here. First three scenarios were same distance, same V1, same V2, but different delay, different T0. It's 1 hour, 2 hours, 3 hours, and we obtain different results for this time from this formula. 3 hours, 2 hours, 1 hour. And we try to interpret some of them. Those two we were able to, and this was kind of strange result. 1 hour with delay of 3 hours. It's kind of strange that they meet after the delay. Very difficult to interpret. And then in the scenario number 4, we inverted the speeds. So this was only 50, this was 100, and so it was surprising that still with 50 and 100, the car was still meeting after 8 hours of travel. After 8 hours of travel, if T0 was 6 hours. And then we figure out, so yeah, the car passing by and this is now catching up, so the car that's catching up has a higher speed, and that's how we interpret it. In the third section, and this is the third video of the previous video, we looked on the picture completely different. We said that we have two bodies moving along the straight line with a constant speed. And as such, we can tell that this formula, x equal x0 plus vt, always is valid, no matter what the body is doing, as long as it's moving with the speed v, this would be the formula. And then we started to deal with the first body, and we figured out that x0 equals 0, because if time equals 0, x equals x0, and at that moment, this is x0 is the coordinate of the body when time is 0. x0 becomes this parameter is 0, so we know that x0 is 0 and v equals v1. So we know that x equals v1t is the formula that describes the first body, and we build some graphs, and we will be building more today, so to address those four scenarios and to interpret those using those formulas. With the second body, we have obtained that x0 equal d minus vt to 0. It's just a number. D is always known, v2 is known, t0 is known, and we will be putting those numbers from those scenarios, and we will see how the graph actually looks with those numbers. So it's not something abstract in characters, but with numbers. And we also know that v equals v2 for this body. Body moves not with some abstract velocity v, but with very specific v2, and it's again would be there like 50 kilometers, 100, and we will put this number. No matter what, if we plug this x0 and v2 into this formula, then we will have this formula for the second body. And let's discuss a little bit how this all will be looking on the graph. So let me put here, prepare this graph, and I will make it long enough and big enough And I know that actually the numbers would be here D, and it would be 200 kilometers. So I put D and I put 200 kilometers because it always will be here. And for my purposes, I extend it a little bit up, and I put other numbers like 100, and I put 300, and I moved a little bit up, and it would be 400, and then this would be X, and then this would be T. And in terms of hours, I see what hours I have here. I have 1 hour, 2 hours, 3, 6, and 8. So I'll put 1 hour, I'll put 2, I'll put 3, I'll put 4, 5, 6, 7, and 8. More or less like that. And this would be my playing field. And I also can put this axis. And I also can say that this is A, this is the same, but tilted, and this is 0, and this is D, and this is point B. And I will play with those two formulas, plugging those numbers. At the beginning, first of all, I say that let's deal with this graph. This graph is extremely simple. Let's say V1 equal 100 kilometers. So if I plug here 100, it would be x equal 100t. And what that means, if t is equal 1, this would be the first point. If t is equal 2, it would be 200. If t is equal 3, it would be 300. If t is equal 4, it would be 400. I can take unlimited number of those dots, but what's important is that all those dots would be on this line, and this line describes this movement, and when t is equal 0, the body is here, the coordinate is 0, and this is very simple how this body moves. In the first three scenarios where V1 is 100, V1 is, in the fourth scenario though, V1 is 50. So when we go to the next scenario, if we plug V1 50, we will receive only 50, only 100, here would be 200, because 4 multiplied by 50 would be 200, and you got the picture. This would go like that, and that's according to the meaning of this graph. V is always the slope. Tangents of this alpha is always equal velocity. And in this case velocity is 100, in this case velocity is only 50. So we will be dealing with those two graphs, and let me remove those, and then I will restore them as needed. And let's go with the second car. Okay, the second car, it all depends how long t0 is standing. It may stand 1 hour, 2 hours, 3 hours, and 6 hours. Let's say, for example, that it's standing for 1 hour. Boom. So, for this period of time, the car is not moving, and the graph is horizontal line. By the way, when the car is not moving, it's like a case when v is equal 0. X equal x0, this is the case of this movement with 0 speed. Movement with 0 speed or staying in place. It's still a straight line, and the straight line is horizontal, and because it's horizontal, tangent of this alpha equals 0 and v equals 0, so this is the same line. Okay, but then it goes, let's say, 50, those three scenarios. That means in 1 hour, in 2 hours, it gains 100 kilometers, and this would be this graph. Okay, this is for scenario t equal 1 hour. If we will discuss the second scenario when it says 2 hours I'm standing, this part would be this, but this part will go with the same exactly slope, because the slope is determined by V2, and V2 is 50. Now with 3 hours, the body will be standing here for a bit longer, but then it will go with the same slope. So again, tangent would be the same, V would be the same, and what would be x0? We can find x0. Let's find x0 in the first scenario. So it would be 200 minus V2 is 50 and multiply by 1 hour. It would be 150. So what that means? That means that if I extend this line, I know that body is not moving, but as far as I am concerned, this formula of this line, this formula is valid no matter what. And if I would like to draw this line, it will cross it here, and it would cross it exactly at 150. So it will cross here. This would be the movement. Of course it's standing, but if I imagine that it would be moving in such a way that at that point B it would be at 1 hour, then this would be this graph. Remember, x0 is an intersection of this graph with an axis. Okay. Second scenario, I again finding this x0 is again at 200 minus, speed is the same 50, right? But t is 2, so it would be 100 only. That means that this graph, if I extend it, it comes to 100, which makes sense. Those parallel lines, they shifted, and this is the intersection of this graph here, and this is x0, which in this case it's 100, right? It's a little bit crowded now, but you can see my point. Now, third scenario, it would be x0, right, equals 200 minus 3 multiplied by 50, it would be only 50. Okay, so this will cross here at 50. x0 is 50. Fantastic. Now let's go to the next scenario, the scenario number 4. In this case, V2 is 100, and we're staying for 6 hours. So for 6 hours we will be staying here, and this would be this, and then the graph will go up at, not at the same slope as I wrote it. V2 now becomes 100, so it goes twice as steep, something like this. Okay, and if I want to find the x0 for this scenario, I still can use this formula. It would be 200 minus V2 is 100. This is 6, would be minus 400. And that will perfectly make sense. If I continue this line, it will come somewhere here, and this would be minus 400, and would be x0 for scenario number 4. So I kind of draw those graphs for each case scenario, but I will remove this now because it's too crowded, and I go through first scenario, second, third, and fourth, building graphs for both cars one by one. So I remove this because it's too crowded now, and I will start drawing it again. And on each graph I I will build only two graphs for this particular set of the numbers. So first scenario, V1 equal 100 and delay is 1 hour. So we go here, then this car at that particular moment starts to move up. This goes up as planned, and this goes up at 50, and they will meet somewhere here at 3 hours, right? At 3 hours they will meet, and in 3 hours this car will cover 300. I just draw not very 100. In 3 hours it will cover 150, right? So it will cover 100 multiplied by 3, it would be 300. So this is my graph, and my graph is not really entirely correct. Let's draw it perfectly. So this would be here in 1 hour, this will be here in 2 hours, and this will be here in 3 hours. So this is the first car graph. This car goes here, and then it goes twice as slow, and they intersect at this moment. This is 3 hours, and this is x equals 300. And that's fantastic. Now the second scenario is a little bit different, because in 2 hours the first car, and it's simple, it reaches this point, it crosses 200 kilometers, it arrives to point B, and this is where they meet, and this is second scenario. Now let's go to the third scenario. Third scenario, the first car is moving for 3 hours, so in 3 hours it would be already here, right? And the second car is still standing. It's standing here, here, and here. So this is where one car, and this is where another. The first car is going, and this is going, and twice as low slope. The slope is much smaller. And so what that's supposed to mean? That's supposed to mean that they will never meet here. But we have a result, and the result shows us 1 hour. What actually that means? That means that if we look intersection of this line, and we disregard the fact that we're looking only for t longer than t0, then they meet here at 1 hour. And this is exactly the explanation of this phantom meeting point. It will never happen. But if we will imagine that this car would move before delay with the same, then this would be a speed. And this is basically a formal mathematical solution when we this and this put together, and we find this as a meeting point. Okay? Now let's go with scenario number 4. And scenario number 4, as you remember, the first car is moving very slow. It's moving only 50 kilometers an hour. It's moving 50 kilometers an hour, and to cover this distance it needs 4 hours. So actually it comes here in 4 hours. So this would be the slope. And the second car, it stays for 6 hours, so it goes like this, and this is the point for second car, but then it moves very fast. So it moves very fast, and they meet somewhere here. So this is V1, and it's very small, and this is V2. This angle is much bigger, and so we have that when 8 hours passes, the first car will cover 400 kilometers, and this car, because it's moving 100 kilometers and it's moving for 2 hours, with 100 this would be 200 kilometers, so this distance would be 200, and 200 is already half, so they meet in this point 400 kilometers away from this point, and it all will happen in 8 hours. So, what is the resume of all of this? The deeper we go, the more knowledge we understand. The first was just this distance, that speed, and we came with a formula which turned out to be correct. We put some numbers, we got something that we couldn't understand. Then we analyzed this in the video 3, in the previous clip, with the generic graphical approach using this formula x equal x0 plus vt, and we received two formulas for first body, for the second body. And now when we plug those numbers in those scenarios, we see all different graphs and how it all evolves. And so actually we can see that this formula works also in a weird cases when the car passes by and this is catches up, and this formula turns out to be way more powerful than we could think first. And also the lesson from this is that it's always better to operate in characters, generic approach, not to plug numbers right away. Because when we plug the numbers, we'll lose a lot. Because, yes, this formula actually means for the first body x equal 100 multiplied by t. Good. And for the first body and for the second body, it means, depending on what you have, it depends, for example, 100 minus plus v2, and v2 is 50, 50 multiplied by t, and we can find t, and it would be the number, but this would be not a formula, but just the number. So the work that we do in that case, plugging numbers straight in the very beginning, means that we have to redo everything when we put different set of numbers, and we have to redo it, and also we don't see the intricacies, we don't see how it's all tied together. So that's why I always solve the problems in characters and put the number substitute with the real numbers in the very end. Now, this third case, when they're meeting somewhere here, it's kind of weird. The correct way would be to have this formula, but also in the end we have to verify that t0 equals. This would be mathematically how we will exclude those conditions. So first scenario will work, second scenario will work, but third scenario will not work because t is equal 1 and t0 is equal 3, and so this will not be valid. So this formula makes no sense, although it gives us a hint and we can explain it, but it's better to have this. So this concludes this 4-part video about this problem. And don't forget to subscribe, don't forget to like, please click the bell, and this way you will not miss my next problem, which will appear pretty soon because I have unlimited supply of those problems here. Thank you.